Okay, so this is out of section 1.5, problem number 36. It says, a tank initially contains 60 gallons of pure water. Brine containing 1 pound of salt per gallon enters the tank at a rate of 2 gallons per minute, and the perfectly mixed solution leaves the tank at 3 gallons per minute. Thus, the tank is emptied after exactly 1 hour. Part A. Find the amount of salt in the tank after T minutes. In Part B, what is the maximum amount of salt ever in the tank? All right, so we need to know several things. We need to know the starting amount of salt. We need to know the concentration in. We need to know the rate in. We need to know the rate out. And we need to know the concentration out. Oh, you want to see? Okay, so there's all the stuff we need to know. Amount of salt at the beginning, concentration in, rate out, concentration out. All right, so I'll read the problem to you again. It says, a tank initially contains 60 gallons of pure water. If it has 60 gallons of pure water, then what's our initial value? 0. Why 0? Pure water. There's no salt in it at all, is there? So our initial value of salt is 0. Brine containing 1 pound of salt per gallon enters the tank at 2 gallons per minute. So what are those numbers? 1 pound of salt per gallon at 2 gallons per minute.
It's 2 gallons per minute. So the 2 pounds of salt per minute.
So what's the flow rate in? 2 gallons per minute. And of that 2 gallons, how much salt is in it? 1 pound. So our concentration in is 1 pound per gallon. Okay. It goes on to say, the perfectly mixed solution leaves the tank at 3 gallons per minute. So what's that? That's the rate out. The rate out is 3 gallons per minute. All right, and then we need the concentration out. The concentration out, that's the hard one to compute. The concentration out is the amount of salt divided by the volume. So at any given time, how much salt is in our bucket of water? I'm not looking for a number. True, it does depend on my volume, but we're going to divide by the volume and fix that. No. It's x. It's not x0. x0 is the amount of water at the beginning. It's just x. X is our function that we're looking for. X is our function, which tells us how much salt is in the tank. So our amount of salt is always x. That's the easy one. Amount of salt is always x. Divided by the volume. How much water is in the tank at any given time? It started with 60, didn't it? Yeah. But what's happening? I started at 60.
You don't have any concentration until after the first minute.
True. I started with 60 gallons, but I've got 2 gallons coming in and I've got 3 gallons going out.
So just minus 1 gallon.
So I'm losing 1 gallon every minute. So I started with 60 gallons, but I'm losing 1 gallon every minute. So there's my volume at any given time. So if this had been 2 gallons coming in and 4 gallons going out, then what would I have had on bottom? 60 minus 2t. Conversely, if I had 3 gallons coming in but only 2 gallons going out, 60 plus t. Okay. In most of the problems you're going to do, and in the problem in the homework, problem in the quiz, I mean, your rate in and your rate out are going to be exactly the same. So that makes it much easier. If your rate in and your rate out are exactly the same, then what's your volume? 60. It would stay right at 60. It wouldn't change. So this one's a little bit harder than the one on your quiz. The one on your quiz, your volume's not changing. Okay, so here's our differential equation. The rate of change of the salt is the salt coming in. The salt coming in is 2 times 1. We've got 2 gallons per minute coming in at 1 pound per gallon. So salt coming in, 2 gallons. 2 pounds, I mean. Minus the salt going out. The salt going out is our rate out, which is 3 times our concentration out. X over 60 minus t. So it's rate in, concentration in, minus rate out, concentration out.
So, why is there a 3 multiplied by the x?
Because it's our rate out. Our rate out is 3 gallons per minute.
Oh.
So it's our rate out, which is 3 times our concentration out. And I just chose to put the 3 right up there with it. All right, now that happens to be a linear differential equation. If we write it as x prime plus 3 over 60 minus tx equals 2. We have our derivative plus some function involving t times x equals some function involving t. Now this function involving t over here is just a constant. That's okay, but it is a linear equation. How do we now solve our linear equation?
In a row.
We get a rho. Rho is e to the integral 3 over 60 minus t dt. That's e to the 3 times, what's the antiderivative of 1 over 60 minus t? Negative ln of 60 minus t. Where'd that negative come from? U sub. Because I have 60 minus t, u would be 60 minus t, du would give me a negative on my derivative. All right, I'm going to take this negative 3. It goes in as an exponent. And then the e and the ln reduce each other. So I get from my rho 60 minus t to the negative 3. Questions on that? Multiply everything by rho. 60 minus t to the negative 3 x prime plus, I'm going to write this one as 3 times 60 minus t to the negative 4 x. Why negative 4? Because there's another one on the bottom, so that's the power negative 1, and then I have a power negative 3. Those add up to a negative 4. Equals 2 times 60 minus t to the negative 3. Alright, if I've done it correctly, this left-hand side should be d dt of my rho, 60 minus t to the negative 3, times x. And let's see, let's just try the product rule real quickly to make sure we've got it right. I leave the first one alone, take the derivative of the second. There's that term. Then I leave the x alone. I take the derivative of this one, I bring the -3 down, I subtract 1 from my power, that's a -4, and then the derivative of the inside gives me another negative, which does make that a plus right there. So that looks correct. Time to integrate. 60 minus t to the -3 times x equals, what's the antiderivative of 2 times 60 minus t to the -3? Well, I'm going to have that 2. I'm going to have 60 minus t. I'm going to add 1 to my power. Divide by my new power. And then I need another -1. Why do I need another -1? Again, this is really a u substitution problem. Really what I'm doing is I'm letting u be 60 minus t. And then my du is a negative dt. We do a lot of u substitution in this class, don't we? Just about every problem. Another negative plus c. All right, so we've almost answered part A. X equals, I'm going to multiply by 60 minus 2 cubed. Those reduce out. When I multiply by 60 minus t cubed, that gives me 60 minus t on that one, plus c times 60 minus t cubed. I'm now ready to plug in my initial condition to find the value of c. What was my initial condition again? 0, because we started with pure water. There was no salt at the beginning. So 0 equals 60 plus c times 60 cubed. So subtract the 60, divide by 60 cubed. c is -60 over 60 cubed, which is -1 over 3600. Because it's 1 over 60 squared. 60 over 60 cubed reduces to 1 over 60 squared. All right, so here's the answer to part A. The answer to part A is x equals 60 minus t minus 1 over 3600, 60 minus t cubed. There's how much salt is in the tank at any given time t, where t is between 0 minutes and 60 minutes. Questions on that? All right, and then part B says, forgot what part B said. What is the maximum amount of salt ever in the tank? How would I find the maximum amount of salt ever in the tank? I take the derivative, set it equal to 0, all that Calc 1 stuff that we did over and over and over again. All right, so x prime is 60 minus 1 over 3600 times 3 times 60 minus t squared times -1. Set that equal to 0. 60, that's a minus and a minus, that's going to be a plus. What's 3 over 3600? 1 over 1200? Times 60 minus t squared equals 0.
What's after the 60 t squared?
It's supposed to be a times -1 right there.
Oh. Not t, yeah.
Yeah, my writing got a little yucky there.
Where does that 60 in the front come from?
Oh, heck, I don't know.
60 minus t?
Yeah, what's the derivative of 60 minus t? It's not 60. How about -1 right there? I was wondering why this equation here didn't have any solutions. I was worried about that for a minute. That shouldn't be a 60 there. That should be a -1. The derivative of 60 is 0. I did all that differential equations right, and I can't do my Calc 1. Sad. All right, add the 1, multiply by the 1200. 60 minus t squared equals 1200. Square root. 60 minus t is the square root of 1200. And it's got to be the positive, well, is it the positive square root or the negative square root? Which one do I want?
Positive, because you're talking about time.
Positive because I'm talking about time? Okay. Then I subtract 60, so negative t is the square root of 1200 minus 60. So t is approximately, left my calculator over there. Square root of 1200 60. Approximately 25.4 minutes. And then I'm going to be lazy here. You would then take 25.4 and plug it into that function. So 60 minus 25.4 minus 1 over 3600 times 60 minus 25.4 cubed. X is approximately 23 pounds of salt. So at one time or another, in about 25 minutes, you've got about 23 pounds of salt in your bucket.
That's a lot of
It's a lot of salt.
Yeah.
Questions on that? There is one last thing I should do. What's the last thing I should do? Move on. No, I'm not done with this question. Before I move on to the next question, I really should draw myself a number line and show that my derivative looks like that, just to be absolutely sure that my critical point is a maximum. I don't know for sure that my critical point is a maximum. What's that? Well, you shouldn't trust me. You have to trust Edward and Penny here, that they wrote a good problem. But
Oh yeah, we have
implicit trust.
Yeah, since you paid so much for the book, you gotta
Okay.
trust it.
Questions on that?
Amen, Max. Amen.
All right then. Today we're going to start section 1.6. In section 1.6, we're going to learn to solve multiple different other kinds of differential equations. And I'm going to start with Bernoulli. Make sure I spell Port Bernoulli's name correctly. Bernoulli. The book does not start with Bernoulli, it starts with different types. I'm going to start with Bernoulli. And the reason I'm going to start with them will become evident in just a minute. A Bernoulli equation is an equation that can be written in the form y prime plus p of x y equals q of x y to the n, where n does not equal 0 and n does not equal 1. What does that look like? It looks an awful lot like linear, doesn't it? Except what's the difference? We don't have this y to the n on the end on linear. How come n can't be 0?
It limits at 1, and therefore we're back to where we started before.
If n is 0, then y to the 0 is 1, so you've got that, you've got a linear equation. So it is still technically Bernoulli, it's also linear, so we don't really worry about it. What if n is 1?
It's why we make it separable.
If y is 1, you can bring this piece over here, factor out the y, and it's a separable equation. So we already know how to do those too. Don't care about those. Well, we do care, but we already know how to do them. Nothing new. All right, so what you're going to do for a Bernoulli equation is you're going to make a substitution. You're going to substitute in v equals y to the 1 minus n. So you'll make that substitution. You'll solve for y. And then you'll find y prime and plug into the equation. And after you do that, after you let v equal y to the 1 minus n, solve that for y, find y prime. You plug in your y prime, you plug in your y, you do all that work. The equation will then be linear in v. So then we solve it as a linear equation the way we solved in the last section. And then after we do that, then we plug our y's back in. Okay, so that's why I chose to do Bernoulli first, because Bernoulli are very, very similar to linear. They solve them almost exactly the same way. All right, so let me grab a Bernoulli problem out of the book. Yeah, this is a very long section. All right, so this is problem number 20. That one looks Bernoulli. Y squared y prime plus 2xy cubed equals 6x. All right, the first thing we need to do is we need to recognize that that is Bernoulli, and to recognize that it is Bernoulli, we need to write it in the right form. So what would you do with this equation? Divide by the y squared. So you have y prime plus 2xy equals 6xy to the negative 2. So it is Bernoulli. We've got the y prime plus, we've got a q of xy, or p of xy, I mean, and then we've got our q of x with a y to another power. So we make our substitution. Our substitution is v equals y to the 1 minus negative 2. 1 plus 2, which is 3. So v is y cubed, which means y is cube root of v, and I'm going to choose to write that as v to the 1/3. I prefer to write things as powers because powers are easier for derivatives. Y prime is then, what's the derivative of v to the 1/3? 1/3 v to the negative 2/3 times v prime. Okay, so I'm now going to take this y prime and I'm going to plug it in there. I'm going to take this y and I'm going to plug it into both of those spots. Going to do a little bit of algebra, and if I did everything right, I should have a linear equation. So we have 1/3 v to the negative 2/3 v prime plus 2x v to the 1/3 equals 6x v to the negative 2/3. Because I plug in v to the 1/3, I've got a power followed by another power, I multiply my powers. V to the negative 2/3. Alright, does that look linear? Nah, not yet. But if we clean it up, I think it will be. I'm going to take this whole equation and I'm going to multiply by 3v to the 2/3 to get rid of that thing right there. When I multiply by 3v to the 2/3, v prime plus 6x v, because 2/3 plus 1/3 is 1, equals 18x, and that's all. Max.
Well, if you multiply both sides by 1/3 and 2/3, right? Well, where's the ones on the right side?
It's,
Say that again.
How come there isn't 1/3 on the right side? How come there's just the 2/3?
This 1/3 right here came from the derivative. It came from the y prime.
Yeah.
Where over here I'm just plugging in for y. I'm not plugging in for y prime.
Oh, okay.
So 1/3. That's why there's no 1/3 over here.
Oh, because it's, okay.
And then that negative 2, I multiplied my exponents. A 1/3 and a negative 2, I multiplied and got a negative 2/3.
Why in the y prime do you have a v prime before v prime?
What's y prime? Y prime is really dy over dx. So when I take the derivative over here, I'm taking the derivative with respect to which letter? X. So this is a 1/3 v to the negative 2/3 dv dx. See, normally when we take derivatives, if we have something like y equals x squared, when we write y prime, we really mean dy dx. So when we take the derivative over here, we get a 2x, and then we would have dx over dx, which would be 1, and we don't write it. Okay, so that's where that v prime comes from. It's because we're differentiating with respect to the letter x, not with respect to the letter v. Okay? You're welcome. More questions? Okay, so we multiplied by this to get rid of that, and it does look linear, doesn't it? We have v prime, we have plus q, p of x v equals q of x. Nice linear equation. Oh, now we roll. Rho is e to the integral 6x dx, e to the 3x squared. Okay, so we're going to have e to the 3x squared v prime plus 6x e to the 3x squared v equals 18x e to the 3x squared. All right, we've seen this a lot of times now. If I've done everything right, I better have a derivative over here, and it better be this e to the 3x squared times v. You can do a quick product rule there and check. It does work. We integrate. I'll do the left-hand side. You tell me what to do on the right-hand side.
we're going to have to do partial. Yep.
It does, when you first look at it, it looks like an integration by parts problem, but it isn't, because you can let u be 3x squared, and then du is 6x dx. Go ahead.
When you take the derivative of, like, to prove derivative of e to the 3x squared times v, so wouldn't it be, use a product, would v be b squared?
We're taking derivatives, though, not integrals.
No, for, when you take a derivative,
Yeah, what's the derivative of v?
b squared, no, 1, right?
Except, again, we're taking the derivative of v with respect to x. So it would be 1 times dv dx. So there's my dv dx right there. Okay? All right, so what's this integral going to be here? This is going to be integral of e to the u du.
Well, if you have to the front, we have 6x.
And if I pull a 3 out, I'm good, because 3 times that 6 that I need would give me the 18. So that's going to be 3 e to the u. So that integral turns out to be 3 e to the 3x squared plus c. You don't like that? V is, you've seen worse. So V is 3 plus c e to the negative 3x squared, because I multiplied both sides by e to the negative 3x squared to get rid of that e to the 3x squared right there. Reduced with that one's left over. One more step. The problem started with y, so we should end with y. V was y cubed. So final answer, y cubed equals 3 plus c e to the negative 3x squared. Yes, we're going to leave it just like that. We could take cube root on both sides if we want, but we don't want to. Is that okay?
How did it turn into negative 3x squared in this one?
To get rid of this e to the 3x squared right here,
Yeah, you divided by it.
I divided by it, or dividing by it is the same as multiplying by e with that negative power.
Oh.
And then my powers there add up to 0, so those reduce. I tend to like negative powers. If you tend to like writing things as fractions, you can write them as fractions. So you could divide both sides and write it that way too. Other questions? I think we better do another one. It's a good idea?
Yeah, the blind man. Blind man. Why you? Yeah, we'll go keep it if I keep
All right, 24 has 2xy prime plus y cubed e to the negative 2x equals 2xy. All right, so first thing we need to do is convince ourselves that it is Bernoulli, which means we need to write it in the right form. How to begin? Divide by the 2x. Y prime it plus. I'm going to switch these around. I'm going to write e to the negative 2x over 2x. Y cubed equals y. Is it Bernoulli?
Nope.
Not, well, it is Bernoulli. It's just not written the right way yet. How do I make it the right way?
Switch the y to the y cubed.
Yeah, I've got to have the y over here and the y cubed over there. To be Bernoulli, it's got to be p of x y on this side and then something with a y to another power on that side. So these are in the wrong positions. Y prime minus y equals e to the negative 2x over 2x y cubed. So now it looks Bernoulli. It has the y prime,
Negative. Yeah.
negative, y prime minus plus p of x y, p of x is just a number negative 1, equals q of x times y to another power. All right. So we recognize it's Bernoulli, we make our substitution. V equals y to the 1 minus 3. It's always 1 minus whatever this power is over here. So that's y to the negative 2. we get y all by itself. What's y? V to what power?
Either half.
Close, not half. Negative a half, because we have the negative 2. So we've got to get rid of the negative by doing a negative power on each side. Then we get rid of the square by doing a square root. Derivative, y prime, negative 1/2, v to the negative 3/2, v prime. Plug our stuff in. Alright, so for y prime, we write negative 1/2 v to the negative 3/2 v prime minus y is v to the negative 1/2 equals negative e to the negative 2x over 2x times v to the negative 3/2. Because again, I'm plugging in the v to the negative 1/2. I have v to the negative 1/2 cubed. Multiply my exponents. Get rid of this thing here, and you should have a linear equation left over. To get rid of that thing, I'm going to multiply through by negative 2 v to the 3/2. That leaves me with v prime plus 2v, add your exponents, 3/2 and negative 1/2 is the power 1, equals the minus and the minus, the 2 with the 2, e to the negative 2x over x, and then the v's, the powers add up to 0. So it cleans up nicely. I hope. Alright. So, you do all that work just to get it to linear so you can do more work to solve the linear equation.
Oh boy.
Bernoulli ones are fun, aren't they?
Yeah. It's like an adventure.
It's like an adventure every time, that's right. You get the same ending every time. Arg! No. Rho equals e to the integral 2 dx. So rho is e to the 2x. And I think I'm going to like that very much, because when I take this whole equation and multiply by e to the 2x, e to the 2x v prime plus 2e to the 2x v equals 1 over x. I like that very much, that this e to the 2x reduced that e to the negative 2x, because that looked like it was going to be a nasty integration thing. It looks a lot better now. Left-hand side factors as the derivative of e to the 2x times v is 1 over x. Integrate e to the 2x v equals ln x plus c. Divide by e to the 2x, or again, I like to multiply by e to the negative 2x. I prefer writing things with negative powers. My choice. V equals e to the negative 2x ln x plus c e to the negative 2x. And then my very last step is I started with y's, I end with y's, I go back up here. V is y to the negative 2. Y to the negative 2 equals e to the negative 2x ln x plus c e to the negative 2x.
And of course, when they start giving us initial conditions, that's when we're going to have to plug in and find C.
Actually, looking at the homework problems in this section, I don't see any that have initial conditions. So you don't have to worry about that. Although that's not the hard part. I mean, it's not so bad. But